Hello everyone, hope you're all doing well and thank you for joining us for another video. Now, one problem with Flat Earth, of the many, is there doesn't seem to be an accurate Flat Earth map. I mean, technically there's no accurate map of the globe either, because a map is a two-dimensional diagram, whereas globes are three-dimensional. So laying a globe out flat will always have some parts that have to be stretched out, hence why there's so many various projections for the globe as a flat map. But if the Earth were flat, then creating an accurate map should be easy. Yet flat earthers seem to struggle being able to present a complete and accurate map. Fight the Flat Earth loves asking flat earthers for an accurate map whenever he's in a debate with them. And usually when I've seen this happen, the flat earther in question seems to try and divert away from the subject.
I've been looking and I still can't find an accurate flat Earth map. Why is this? I
mean, do you have an accurate map, period?
However, the other week he had a debate with Flatzoid all about celestial navigation, and Flatzoid was trying to argue that there are accurate flat Earth maps.
You've been through this.
Why are you ignoring my request, please? Flatzoid, for the last time, please, put on your screen a flat map that shows the accurate sizes of countries. That's all I want.
Okay, guys, let's do this again for Mr. Not Understanding.
And it has to have accurate sizes of countries, all right? 100%.
Multiple charts.
But they don't have accurate sizes of countries on them.
There we go.
We've established that. Yeah, we've established they don't have the accurate sizes of countries because it's based on the Mercator projection.
So this is the map that Flatzoid was presenting as being accurate. You can find this at map.openseamap.org. Now the problem is this isn't an accurate, complete-to-scale map. This is the Mercator projection, which is what we most commonly use for world maps these days in things like atlases. Speaking of atlases, a quick shout out to Atlas VPN for sponsoring this video. I've been using Atlas VPN now for quite a few weeks and I frankly had no idea just how many trackers are around, even on the most common of websites, and it was able to detect and block these whilst I was online. There's also the breach scanner tool, which allows you to check your email addresses to see if any website logins have been compromised. And the other great feature of the VPN is you can select which country your data is being rerouted through. So I can decide which country I want particular websites to think I'm viewing from. But most of all, I like the fact that I can put it on as many devices as I like. And if you use my link down below, you can not only pick up a 3-year subscription for less than $2 a month, but you'll also get an extra 3 months on top absolutely free. And all available with a full 30-day money-back guarantee if you're not completely satisfied. So why not head on over and check them out today? For a map to be accurate, you need to be able to measure distances across different points of that map. For example, if you take an Ordnance Survey tour map, those are usually a 1 to 100,000 scale. Meaning if you want to know the distance as the crow flies between two places, you can measure that distance on the map, multiply it by 100,000, and that will tell you exactly how far away those points are in real life. So if the points on the map are a centimetre apart on a 1 to 100,000 scale map, then in reality those places are a kilometre apart. And that applies to any 1 to 100,000 scale map anywhere in the world. Doesn't matter where you live, if you measure 1 centimetre on a 1 to 100,000 scale local map, then those two places will be a kilometre apart. And we can do the same thing with a globe. Take a piece of string and put it between 2 points. Let's say along the equator from the west coast to the east coast of Africa. Now I can take that same piece of string and it will fit across Australia perfectly along the Tropic of Cancer between Exmouth and Rockhampton. And I can do the same thing up in the northern hemisphere. Let's say we start the piece of string at the French-Belgian border at the coast and we follow that latitude line around, and it puts us right where the east side of the Urals meets the border with Kazakhstan. So those are three different pairs of points from completely different areas of the globe. If we now pull up Google Maps and measure those distances between them, sure enough, each pair of points show a distance of somewhere around 2,400 miles. Yet if we measure those distances between the points on the Mercator projection, they're all wrong. The distance across Africa is showing physically shorter than the distance across Australia, and both are significantly shorter than the distances across Europe. If we try it on the AE projection, then 2,400 miles across Europe is now shorter than 2,400 miles across Africa, and both are shorter than 2,400 miles across Australia. And it's not like you can just move and resize the land masses to make them accurate, because then the distances between them across the oceans would then all be wrong as well. And this is the issue that FTFE was trying to bring up with Flatsoid. There is no complete flat map of the Earth that keeps a constant scale while showing accurate distances between any and all points. But if the Earth were flat, then there's no reason there shouldn't be one. Flat Earth, flat map, it would just be a scaled down representation with accurate distances all over it. Now, Flatsoid begins arguing that whilst the Mercator map isn't accurate because it's a projection of a globe, nautical charts are accurate, and those are a projection of the Mercator map.
So that goes back to my question of where is the accurate map, the accurate flat Earth map that you will base celestial navigation on?
Nautical charts.
But which nautical chart? The one based on the globe projection?
None of them are based on globe projection.
If it's the Mercator map, then that's the globe projection.
The charts are based on the Mercator, and
which is a globe projection.
Now, nautical charts can be very accurate, just like Ordnance Survey maps can. But the ones with a high degree of accuracy only cover relatively small areas within each chart, mainly to allow for more detail, because they include things like local tides and sea depths that you couldn't put all across a giant map of the entire world. But in dealing with such small areas of the world, the amount of distortion that they would have from being flattened out based off a globe is then minimal. Single nautical charts of the entire world still use inaccurate projections like the Mercator. I mean, here is the Berlin nautical chart of the world from back in 1778, and you don't need to be fluent in French to spot a keyword there. So FTFE then pushes Flatsoid that if nautical charts are accurate and those are projections of the Mercator, and the Mercator is a projection of a globe, then the globe must be accurate.
When you say that the Mercator map is based on the globe, and I agree with you, and you then say that nautical charts based on the Mercator map are the accurate thing for celestial navigation, you are conceding that they are based on a globe projection. Your own words.
And what is the globe based on? A grid system, correct?
The globe is based on an accurate representation of the Earth. The globe, the thing that I'm holding in my hand now, has accurate representations of land masses, their size, the distances on them, the distance between them. Just like the AE map is a projection of the globe. Just like every single flat map is a projection of the globe.
Okay, now, is that a grid system or not?
The globe is not a grid system, no.
So if you didn't have a grid system, you'd still have a globe then?
You can put a grid system on the globe, but the globe is not a grid system.
Okay, then show me how to get a latitude and longitude on your globe without a grid system, please.
I never said you could. Yes, again, the grid system exists on the globe because we put it there, but the globe existed before the grid system. For the globe to be based on the grid system would have to exist before the globe.
Yes, the grid system did exist before the globe.
Could you please give me a citation for that?
It sounds like Flatsoid is arguing that the grid system of latitude and longitudes were first created and then the globe idea was built around that, rather than the globe being established first and then latitude and longitude being placed over it. The Earth was first proposed as being round by Pythagoras in 500 BC. In 350 BC, Aristotle declared the same thing, and 100 years later, Eratosthenes did his experiment at Alexandria to prove the circumference of the Earth. The notion of latitude and longitude as a coordinate system was first put forward by Hipparchus somewhere around 150 BC, and he placed a meridian line through Rhodes. But there was no way to actually use this information to navigate with because you'd need a very accurate clock to determine your longitude, and those didn't exist at the time. But much like maps of old, there was no standard for longitude. Hipparchus had placed the prime meridian for ancient Greek maps going through Rhodes. Ptolemy had placed the meridian lines of his maps going through the Canary Islands, as did Mercator when he produced his globe in 1541. It wasn't until the 1800s that Greenwich was recognised as the prime meridian line, and subsequently that became zero longitude. And it was only by 1762, with the invention of the Harrison clock, that people actually had a method of accurately determining their longitude whilst at sea. So the latitude and longitude grid systems that we have in place on the globe today are less than 300 years old, long after the globe model was formed. And that still doesn't address the issue of where is the accurate flat map.
Now,
there's no scale on the Mercator map. Right?
500 nautical miles to 1,000 kilometers.
Yeah, but that's not the same everywhere across the whole thing. That's because the country sizes are not accurate.
Each block has a scale value.
Oh, dude, that's not even a scale. That's a conversion.
Now, a scale value. Now, when we zoom in to a place, you see those blocks. They got smaller.
Now, I might be misunderstanding Flatzoid here, but it seems like he's arguing that the grid boxes, combined with the measurement key in the corner, gives you an accurate measurement of distance, so therefore the map is an accurate depiction of Earth. Except an immediately apparent characteristic of the map is that the grid boxes aren't consistent. The measurement in the corner, for example, when the equator is placed across the middle of the screen, states that the longitude lines are spaced a little over 2,000 kilometers apart. And yet, the moment we begin to move up or down the map, you notice the measurement tool begins to change, and stating that the distance between the lines is shrinking as we move towards either pole. We can zoom into different parts of the world and check this as well. If we zoom right the way in at the equator, the smallest that the grid squares get to is 30 meters across. If we move to 45 degrees north, fully zoomed in, they're now only 20 meters across. But we get the same measurement at 45 degrees south as well. Right the way up at 85 degrees, either north or south, the longitude lines are now barely 2 meters apart. And I was actually watching this stream live when it went out, and I did chime in to try and hint this to Flatzoid.
Dave McKeegan for £5 says, Flatzoid, fully zoom in on your open sea map at the equator. The squares are 20 meters wide. Then zoom in at Norway. Each square is 10 meters wide. How is that an accurate map?
So the grid changes, the scale changes. Congratulations. It's all grid system based.
Which means there's no accurate scale.
It's accurate to the position where you are situated.
So
why do you think I asked you in the beginning? Why do you use
scale changes based on where you are on Earth.
Listen. Why do you think I asked you in the beginning? Why use different scales when going out to deep sea compared to when you are close to the coast? There's a reason for that.
An accurate depiction doesn't have a varying scale. I mean, I have some models on the shelf behind me there, which are 1 to 72 scale, meaning I could measure any individual part of those and know that the real part would be 72 times larger. They don't have varying scales across the different parts, otherwise it then wouldn't be an accurate representation. If we take the open sea map that Flatzoid's presenting and we zoom in and we screenshot these sections and try and piece them together, if you put a new piece in and align one corner of it, you quickly find that the other corners aren't aligning properly to the neighbouring pieces. You would have to start distorting the map to get it to fit. To get an accurately depicted representation of Earth, you need a consistent scale right across the board. The problem with that is, you wind up back with a globe. I mean, this one has a scale of 1 to 42 million, which means anywhere, any 2 points between this, you measure the distance between them, multiply it by 42 million, and you'll know how far apart those places are in reality. I mean, I could take any 2 points in the world, go to any 2 places and measure the distance between them. I could then go to a completely different part of the world and find 2 places that are the same distance apart there. And when I compare them on a globe, I'll find that they're the same distance apart on the globe as well, which proves that the globe is accurate. If the Earth were flat, then that shouldn't be the case, because the globe would then be a projection of a flat map. And so the globe should actually be distorted, and the measurements would then be inaccurate. Yet there isn't a single flat map that can show accurate sizes and distances for the whole world at the same time. Anyway, that is going to conclude this video. As always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please consider hitting the like and subscribe buttons, and then hopefully we'll see you in the next video.